All right, logical expression and operators. We're talking about truthy and falsy. Truthy and falsy is, again, we establish pretty weirdness with JavaScript, but quirky is not the word. It's quite strange. If you're used to a strongly typed language like Java or C#, it's a little different for sure. Ternary operators. So truthy and falsy, I think we kind of already touched on it a little bit, but every value in JavaScript has an inherent Boolean. That's one thing you got to remember. So when the value is evaluated in the context of a Boolean expression, the value will be transformed into its inherent Boolean value. Dense, it's very dense. You have to reread it. It's very strange. Every value has a Boolean true or false. And sometimes it gets, well, not sometimes, many times you can just check that it's there. Like if it's not defined, if it's defined, it'll be true. If it's undefined, it'll be false. And there's a table that kind of explains this. This is really the root of some really weird bugs. In vanilla JavaScript, and when I say vanilla JavaScript, I'm talking about what we're learning here. When you get into some frameworks, they protect all this weirdness with their own strongly typed mechanisms, right? So a falsy value, a value is falsy if it converts to false when evaluated in the Boolean context. So for instance, an empty string is falsy because it evaluates to false. You already know if else statements, so you could use it. You could test the truthiness of empty string. So if empty string, which will evaluate to false, then if it's true, it'll evaluate to this. If it's false, it'll evaluate to falsy. So if we use our playground here, let's try it out. So if we had, hey, for some reason it's not allowing me to do this. All right. 1 second here. Reload. There we go. All right. So sometimes you can actually write, if it's one line of JavaScript without, you can actually write without those braces, curly braces, right? Curly braces. Without the curly braces, you could actually write, if you have one line, one sentence, one line of code, it'll actually know it's not a block. A block of code would be more than one sentence. You could write it in this way. This is falsy. This is truthy. So it's going to evaluate this expression. So if we run this, it's going to fall through. It should say, well, if it wants to come back to me, oh God, what's wrong with this thing? The expectation is that that would be this statement here. Now maybe this is being very particular because it's not giving me any, maybe it wants this type of, it wants my angle brackets. Maybe it wants me to say else with my, maybe it wants me to close off all of my tags. Let's see what this says, stop. Oh, there we go. See, for some reason it didn't like, you know, it doesn't tell you there itself. See, it didn't like the fact that I had no curly braces. I was just telling you that. So it didn't like that, this, whatever this compiler, but the browser itself will allow you to do that. Let me see here, somebody had a question there. Can you explain what the meaning of that does against the condition? Yes, this is very weird. It's strange. And this is what the slides are gonna get into, right? So we gotta go back to this. This is a very quirky thing in JavaScript. It's very strange, truthy and falsy. So reading that dense statement again, every value in JavaScript has an inherent Boolean value. The compiler, like the browser knows this. So when the value is evaluated in the context of a Boolean expression, it will be transformed into that inherent Boolean value. So it's very strange. It's very strange. Why does this empty string evaluate to false? Many times you will see things in JavaScript like this. Even to this day, I sit there and I question myself sometimes, because you'll see something like this. You'll see, okay, I have a variable called, is is search enabled. Okay, and it's equal to empty string. Now maybe that value is set in a cookie. Maybe a cookie is a way of storing flags in the browser. So maybe somebody has turned it on. I'm expecting true or false, but if it's not there, sometimes I can check the existence of it just by going like this: is search enabled? Just like that. It'll convert it, whatever value this is, it'll convert it into one of these conditions, true or false. So in this scenario, it's really not there. It's empty string. It's not. It converts to false. If it was true, as I expect it to be true, then that, or false, a hard false, those I can work with, right? I know what those are. But when you get into those weird situations where, it's an empty string, and not just that, it could be something like, we have a concept of undefined. What does that do? That one is truthy. Why is that truthy? Type of, there's actually a type of, well, that gets more advanced, but anyhow. If it was in fact undefined, a type of undefined, it would actually give a falsy, I believe. Right, this is weird. This is strangeness. There's a table there's another table to explain this. So falsy values. So here's a list of the falsy values. Boolean is false. Okay, we know that. The null type is false. Undefined is false. 0 is false. Empty string is false. And the odd NaN, you'll see it sometimes as not a number. That's also false. There's 6 falsy values in JavaScript. And this, to be honest, is very powerful, but also, the check itself is powerful, but it's confusing to get, because, you have true false is fine. I understand that. Null happens a lot. Undefined happens a lot. And then these other ones are, 0 and empty string. Yeah, so you may have an object that is null. Maybe somebody passed a null value and it means it's not there. That'll be false, right? So this would evaluate to false, and then it'll flow through this one. And then they're also saying that 0, which again, 0 is, if you look at an and or gate, and this is going back to circuit. I was trying to explain circuit diagrams back in university. This is the and gates, and or gates. So you kind of have like an and, A and B both. I don't know if you can kind of break this down, but here would be better representation is that they have A and B translates to zeros and zeros, right? 0, 1, binary. And yeah, so it's, to be honest, some of the stuff is, I'd have to refresh myself on this, but really this is where it kind of comes from, is and ors. I don't know if that helped you at all, but that's where it does come from, and, or, NAND. So not and, not or, not, and XOR. But that doesn't relate to JavaScript. So JavaScript is strange in itself. So they're saying that there's these values. So null type, and this is not me saying this or doing this. This is JavaScript doing this. This is really a very odd concept. But so it's kind of handling all of the negative values all in one kind of grouping. False is false. Okay, null, that's kind of there's no presence of a value there. So null is a null type. Undefined, there's no presence of a value there, so it's falsy. 0, truly, if you got back to 1 and 0, as 1 could be considered false in those AND gates circuits, and 1 is true. So okay, I could understand that one. Empty string means, okay, well, there is not really a value there, it's empty. So in a way, that's falsy as well. And then the not a number check, that's a weird one that you'll get sometimes. Sometimes when you try to add, try to do some kind of parsing on a value or try to add a computation to a string, it'll throw this kind of exception, not a number object. So this is kind of handling all the, I don't want to call them negative values, but all of the values where there's all of the cases where there's no presence of a real value. There's no value here. It's kind of what it's trying to get at. And there's 6 of them. And you will often see in JavaScript, you will see it. Many of these kind of checks, I've done it myself. You will see, okay, is search, is it not equal to null? Okay. Also, and is search something called type of, is search equals to undefined. All right. And then also you'll see, but then you don't need to do all these checks. What they're saying right here is that each one of these evaluations of these expressions can be handled in that conversion of the truthy value. You can just, it's smart enough to know that it can just evaluate all those cases by evaluating the value itself. Because in behind the scenes, it'll convert itself to true or false. So in this clean way, you can actually really check for all of those things. And you can also negate it as well and say, okay, if it's not truthy or if it is truthy. Very weird concept. Very weird, very strange. Any example for NaN? So NaN is getting into not a number. So let's look at our, if this can go away. All right. Our web docs, N-A-N, NaN. So you'll see it goes into truthy and falsy numbers. NaN, the global NaN property that represents not a number. So not a number. So it is actually a built-in object called NaN. So not a number. You may throw it out there as saying that, you know, if there's something that happens, I tried it. Not only, maybe I tried to parse something that failed. I tried to do some calculation against something like a Boolean value. Maybe something like that happened. Hey, let's see if we can break it. Let's see if I can get this to work here. Maybe if I did something like console log, well, actually, this might not work here. If we look at our console log in our developer toolkit here, I'm going to clear my console here. There's this button here to clear it. Let's see, can we do false divided by 5? What happens? 0. Gave me a falsie. What would trigger a NaN again? So if I had a string, if I had something like this and I try to divide it, NaN, right? Because I can't divide a string by a number, so it gave me not a number. False is weird. It did something strange there, right? So what if I had a, I'm sure if I had a date or, you know, a new date, I divide it by 4, what happens there? It gives me something there. But if I had an object, I'm sure, and I try to do something, I'm converting that for sure. Usually it's a string value divided by something. Okay, 0 over 0, let's try that. So what was the question here? Question here. False basically equates to 0. 0 can equate to false.
Mike, are you sharing
Yes.
something? Okay.
Yes. 0 divided by 0. There, not a number. There you go. Yes, go ahead. Oh, sorry, you're asking me if I'm sharing.
It's okay.
Sorry, I'm sharing now, yes. Thank you. Yes, so it's very strange, very, very, very odd. So NaN is not a number. So if you divide a string by a number, it'll throw this NaN up. So this is all presence of values combined all in this kind of group together in this falsy value. So it's very strange. Truthy values. So a value is truthy if it converts to true when evaluated in the context of that condition. So for example, 1 is truthy because 1 evaluates to true. And it's strange, but again, the engine does this, right? The language. So let's use it as an if-else statement to test it out against. So we said if it's 1, it'll evaluate to true, and it'll be truthy. So if we run that in our REPL, this is 1, it should be truthy, which it is, truthy. All right, what happens if it is not empty string? What happens if it's, you know, should be, okay. If we run this, that's truthy. If this is a true value, that's truthy. If it's a integer value, like a real one, that's truthy. What happens if it's negative? It's fine. But if it's 0, it's falsy. If it's false, it's falsy. If it's empty string as well, falsy. If it's, let's see, if NaN, if I can, I'm probably not going to be, probably has to be typo, but let's see, falsy. Strange and very weird things. So here's the list of truthy values, and I would say this is one of the most confusing things, to be honest, because you'll forget about this. If you're programming JavaScript 5 years from now, you'll still be like, you'll still be caught up on something, some defect or something. You're like, I didn't know what happened there, and you really have to step through it and really kind of look at it. I even, yeah, sometimes the conditions don't make sense, and you try to do things the long way and use those triple equals all over the place, but really it comes down to truthy and falsy, the root of many bugs. So here's a list of truthy values. True is a value, true. 42, okay, true, it's a real value and a real integer, a real number, so that's going to be true. Pizza is string, that's making me hungry, but it's a real string, it's not empty, so that's true. That's a weird one, 0 string, but 0, because it's not an empty string. It's actually a value. Same with null and same with define. They're trying to trick you here. It's a good trick because those are actually strings. And then an object. So this is a concept of an object. We haven't learned that yet. Is those two braces would be an object, and then the square brackets is an array. So these are all true because they're basically setting themselves up as there is a value there. Yes. So much weirdness there. Again, if you need further reading, which probably, to be honest, even to this day, I still need to look at some articles and just be like, okay, I got to look at this in a different way because it catches you so much. And if you don't get it the first time, don't worry, because you're going to always be going back to this with JavaScript. So some other readings on it. In JavaScript, the truthy value is considered true when encountered in a Boolean context. Here's a list of the falsy ones. And this is basically giving all of the blocks in which this would be true. Even infinity is true. Even negative infinity is true. That's crazy. Falsy, same thing. So same deal. I mean, but sometimes you'll find a good article on explaining some of this stuff. It goes back to the type conversion and how it converts the type. Again, protected in other languages, so we don't deal with this kind of thing. But here's some comparisons, right? False and a dog is false because this is a false value and this is a true value. But 0 and a dog is 0, which is false because this evaluates false. Oh, it's weird stuff. This is truly weird. You know what? If I come across, I remember an article that really made sense to me that I could read through, but yeah, just for now, take it as you're going to be confused by it. Just accept it because it's just one of those weirdness that's going to happen throughout our journey here. That would never happen though, and that would never really happen in some of the strongly typed language. So yes, that's a plus for strongly typed languages. So ternary operator. So sometimes you might find yourself following a conditional. This code works, but it's really lengthy. So there's a way to compress things, and this is found in C# and other things like that. So you may have a very long statement here that looks, it's not very long, but you can compress it in a very small way. So here's a variable called isGoing equals to true, then there's a color. And then basically you're saying if true, then the color is green, otherwise color is red. But we're taking we're talking 1, 2, 3, 4, 5 lines of code to get to this. So we have a short form way where we have a question mark Some people call it the Elvis operator because it kind of looks like Elvis's haircut. If you don't know who Elvis is, look him up. Kind of looks like a little bit of a little hair mullet thing with his. Anyways, they call it the Elvis operator, but it's a way of combining or shortening these big if blocks into one line. So basically, your conditional, then the question mark, if it's true, if it's false. Let's take a look at that. So how I would write something like this is I could just do it as well. I could say okay, I could say is A is 5 greater than 10? If it is, then console log okay. Otherwise, what have you? No. Something like that, right? We can use it in that way. So let's see if the browser respects it. In my console, I'll clear my console. Let's see what it says. It says right. It says no. So it did it. Hooray. If I said this was 500, 5,000, okay, right? So it's a way of doing the full if statement in one line. And again, you could have many, you could have the result of something be like, result equals to, 400 greater than 10. Give me back okay, otherwise give me back no, right? And then I have something in my storage variable is the result of this operation. The long way to do that would be something like this. The long way to do it would be, result equals. You'd have to put a conditional around everything. You'd have to have an if statement in there, and now it gets a little messy, right? Now we have 10 greater than 50, and then you'd have to probably have your parentheses in there, and you'd have to build it out. I can't type in there. Right, you'd have to have, yeah, you probably have to have variable result 2 equals to, an if statement, right? This whole if block, maybe something like that inside of there, and you have to probably have a return keyword, and you have to return no, right? So already right now I've probably lost it because it's like the coding it's all over the place, right? So what they're saying is you can quickly do all of that in one line, one nice line, the ternary operator like this. Nice and clean. Nice. So it's a way of minimizing code. It's a way of reducing, lines of complexity. But you have to know what that that means, right? Otherwise, so why isn't ternary operator? Why isn't ternary operator used all the time? Some people don't like it. I've been on teams where they don't want to see lambda expressions, which is another thing. They don't want to see ternary operators. They want to see the code. It's sometimes hard to debug through. We'll get into debugging at some point. If it's a straight kind of simple thing, simple check, like something like this, is the feature on or not, give a value back, that's perfectly fine. If it's something more complex, like an if block, like a very big if block, like if we had some other calculations going on here, right? Calcs, calculations going on here, maybe we had other lines of code, otherwise also here, process, transaction, there you don't want it being controlled by a ternary operator. You want to be able to go inside of this if block and really step through what's going on in there. Otherwise here, if you have something very highly complex in here, it can get really messy. So if it's very simple, or maybe meaning a couple lines of code, it's good to use ternary operators, maybe 4 or 5 lines of code, that's fine. But if you're using this little question mark to handle like 100 lines of code blocks, that's bad. So yeah, it's quick and dirty, but I like it. It saves a lot of time. Right. All right. On that thought, just give me 1 second. I'll be right back. All right, back. So really, I could probably say, you know, if my oven was on, right? If the oven is on for too long, then what? Console log burn down my house, right? If I burn my house down, then I could probably have another nested if in there saying, do I have insurance? And then I could, I could really get through all of this, right? So hopefully the fire alarm doesn't go off, but I'd check my oven. Right, turn on operator. So if you hear alarm go off, it's because there's too much smoke. So forgot there, because this is so interesting, Turner operators. So this is what it is, and you can also stack them. That's the other weird thing about them, or good thing, that you may get into stacking them. So you may have a ternary operator such as if we had, all right, so if we have a result, we have one flag that is, okay, based on is search enabled, then do something else. Maybe I do some other expression where 5 is greater than 10, but you may have some other logic here. Then return, do something, console log, or return okay, otherwise return not okay, no, right? So you can already see here, this is one expression, and then I close this, or I have the other expression is, okay, exit, right? So if you notice, this evaluates to true, it'll go into this block, which has a ternary operator in itself that returns an evaluated expression there. Otherwise, if it's false, just go to this value here. So you can really nest them, and then they get kind of confusing, right? If you're confused by this code, yes, because you're like, what the hell is going on here? Because I can't tell what's going on, because it's inline and it's not very descriptive, right? And you want your coding to actually describe what's going on, and this doesn't tell me what's going on. It's just a bunch of stuff happening, right? So ideally, after the next class, we'll find a way to describe our code, because if you have a lot of inline stuff like this, you might as well just look at minified code, because it's not going to make sense. But you could do that. You could certainly stack the ternary operators very nested, very deeply, and then you would step through it and be able to evaluate each expression in a better way. So nice short form. It's nice. Sometimes I forget about it, but I use it all the time now. Right. There's actually a double Elvis operator in C# that I'm getting confused with, but that's something else. All right, ternary operators. So you can rewrite those previous codes using the operators, right? So we had that other if block, so now we condensed it really small. We have the color is going true, false. If it's true, then return green. If it's false, then return red, console log the color. Nice and clean. 3 lines of code. A lot better than the other code block, which was over here, which was 1, 2, space 3, 4, 5, 6, 7, 8, 9, 10 lines of code. We compressed it down to 3 lines of code, and to me, it's very clean what's going on there. The whole thing about it was knowing what this ternary operator was doing and what it is. That's the whole thing about learning a language, is learning these little tiny syntaxes that if you didn't know what it was doing, it would be very confusing, right? So That's what it does. So this code not only replaces the conditional, but it handles the variable of assignment for the color, because the result of all this is going to give us back a value that is assigned to color. So if you break it down, the condition is going is placed on the left side of the ternary operator. I call it the Elvis operator. The ternary operator, then the first expression after that question mark is what will be run if it's true. The second expression after the question mark is what will you run, what will happen if the condition is false. So if is going is false, then it's going to skip green and it's going to return red. If it's true, it's going to evaluate the true, and this would be the condition as if it was if true, then do this case, else that case. All right. Right, to recap, so one of the core uses of the ternary operator is to quickly assign a variable to a variable with as little code as possible, and written in the form of condition, true statement, otherwise false statement. So that's a good way of saying it. Test the condition. This is the true statement if it's true, otherwise. So this double colon here is going to say false statement. If you notice, we have this syntax of let. We don't know what that is yet, but it's kind of like var. It's just more powerful. It's saying, so you can consider that like a var. Let x equal to 7, and then we are gonna assign y to something, but we're gonna test. We have a condition here. Is x greater than 5? 7 greater than 5? This is kind of like our ternary operation, or to let us know that this condition will be tested first. The result of the true, which it is true, is x is larger than 5. Else, this is the else syntax. Else would be x is smaller than 5. So a very kind of compact way of showing what how to write some if statements. So pretty cool there. All right, so switch statements. Switch statements, we got a way of compressing code in a way. If you noticed already that we had a lot of nesting going on, switch statements is another way to further clean our code. So if we ever run into this situation here, if you find yourself writing a lot of if statements, it gets kind of convoluted. So each condition is based on the same value. So you have a value of option, and you keep testing option all the time, and you keep having to add in your code an extra else if to handle. If I said to you, all right, now check for up to 10, you would have to go either type it or copy paste the same check. Option equals 7, option equals 8, option equals 9, so on and so forth. Then it might be time to use something called a switch statement. So this is what it looks like. This is a nice statement. In many languages, it's always used in one shape or another. So instead of all of those if statements, we have something called a switch. So we check the option, and it flows through the cases. So case 1, do this, case 2, case 3, so on and so forth. So you can already tell just by comparing this to the switch, it's nicely indented. It has a nice format to it. I can tell nicely where I'm going, and also, well, I'll tell you in a second, once it satisfies the case, it doesn't need to evaluate anymore, whereas back inside of the if block, it needs to, well, at the same time, depends. Like, it'll evaluate each time all the way down, and it'll do this evaluation every single time. Whereas the case, it kind of flows through, right, till it hits what it needs to hit. So I guess the lookup or the processing time would probably be a lot quicker, right? It does a quick compare on the result without having to do an expression. All right, so to follow up, we'll just read this. Switch statement is another way to chain, so we call chaining. Chaining multiple else if statements that are based on same value without using conditional statements. So it cleans it up a lot better. Instead, you just use a switch, which is a piece of code executed on a value. So here each else if statement is usually the option with the triple equals in the value, that we replaced it with the case clause, which is the case and value. So those cases have been wrapped inside of the switch statement. So if we wanted to quickly write a switch statement, we could take our, I don't know, we had something similar, right? Okay, we could have something like, I don't know, pizza, right? That's our variable. Dinner, right? If dinner equals to pizza, and have this block, right? I'm already building my blocks out, and I'm like, oh, this is painful. If it's beer, then do something. Don't have beer for dinner, but if you do have it, enjoy it, I guess. If it's I don't know, whatever, barbecue. So I'm already doing a lot of plumbing here, right? I'm getting tired just doing this. Now I have to do something else, and I have to handle this other block, right? And then I'm already kind of getting tired of it, to be honest. So console log. Copy paste, or we say in web development, reuse and apply. Just make sure that if you reuse and apply, that you make sure you change the same values, right? So watch me type here. So I'm already getting tired of this, to be honest. Right, so let's do that. Does that work? Moment of truth, right? So, but now when we're running it, we have to check each case. So anyhow, that's a lot of extra work, and we could easily accomplish the same thing doing a switch statement. So we have switch, and we have dinner, I believe. This block, see if I open up my brace, I need to close, this will automatically help me close my brace. Give me some spaces here. Add one case statement. So then you have a case something like that. And there's a concept of a break, which is nice. Basically what would happen is when you find the matching value, it'll actually break out of the syntax, it'll break out of the call, so it won't execute anything more, which is really good on performance. So anyways, and there's also a concept of a default value, which a default value could end up being something like this, none, right? So you could break there. Already I'm liking this much better. It's a lot less brackets, that's for sure. And then I'll console log none. Right, so I don't want to look at this anymore because it's too many brackets. I like this. It's nice and clean. Console log pizza, console log beer. I want them all at this point. So for me, that looks a lot better. Will it run? Moment of truth. Reference error. Console log is misspelled here somewhere. Console, there it is. So if you notice this REPL here, this is so much easier than my browser, reloading all the time, so I quickly can find none. It doesn't like it because I don't have it, so that worked actually, good. So as you can tell, I had barbecue, but it went through here and it didn't find it. This case failed, or it didn't fail. It skipped to the next. It skipped to the next. There was no other case there, so it fell through here. So it's none. So if I change this to beer, it's going to actually find it here. This undefined is just the quirkiness of the console. So anyhow, this is compact, really nice. I'm liking what it looks like now. So that's the switch statement. Again, another mechanism or syntax to clean your code up a lot. So when the switch first evaluates, it looks at the case clause. We'll call it a case clause. Expression evaluates the same value as the result of the expression passed to the switch statement. Then it transfers control to that case clause executing its associated statement. Right, so in our example here, it will evaluate down to beer. This case, then it goes inside whatever this block would be, which happens to be a console, but it could be something else. It could be another path, right? It'll basically execute that and then break out of the whole thing. Break out and continue execution on here somewhere down. Continue execution. the program, right? So this break will mean break out of the switch statement at this point, and then control continues right down here. So a lot cleaner, much like the ternary operator. So the break, so I already kind of mentioned the break already. So the break looks like this. The break statement can be used to terminate a switch statement and transfer the control of the code to the terminate statement, following the terminate statement. So if you break out of case 2, whatever, so this switch now will be terminated. Whatever calculation it has done or side effect or whatever happened in the case will go off and be processed or is processed. Control will then be outside of the switch block. So outside of the switch block will then execute. So by adding a break to each clause, you fix the issue of the switch statement falling through to other cases. Yes, you don't want it falling through. Much like, you may have an if statement going through all of the ifs. You don't want this falling through to the next, to the next, to the next, right? Because it may hit case 2, evaluate this, and fall through to 3, 4, and 5. When it sees break, it means terminate. There's other ways. There's other mechanisms to exit blocks and break out of blocks and things like that. Otherwise, you may have some kind of logic that keeps running and running indefinitely. So having things like this help you terminate those threads. So fall through. So falling through, I already mentioned default. So falling through, if you have those situations where you have that fall through behavior of the switch statement, you can use it to your advantage. So if you have a case that doesn't get matched, you may have something like some value that, in our example, we had barbecue, we might as well have, I don't know, steak, why not? Or buttered chicken, why not? Right, so this will fall through. It will not have anything. We could have 100 cases in here, but it will fall through, and then we can catch it. Catch it in there. There's a concept of catching in programming, and in this way we can capture it before it falls through completely and exits out and continues on here. We can have this default. Case, and if we run it, it'll actually hit that default case. So the fall through will actually be captured at this point in time. So without it though, we run it, then it just doesn't do anything. You can see here, undefined. So it's basically fallen out of our switch completely and then continued on with executing. But we want to grab onto it before it leaves us. We want to do something with that case. You may not, but it's always good to have, even if you don't have execution, it's good just to catch it and break it so that it doesn't run through, cleanly terminate execution of this block by having a nice default break, kind of ending the circuit. All right, so that's called the fall through. All right, so you may have something like this. Now again, this is a bigger piece of code, but sample switch statement again, has to do with Node.js, and it's getting something from the read line, like the console, where instead of having a browser, we would be then working with a console, like a server. So we would be doing command line. We can read stuff off the command line with some of these libraries. So here it would actually, much like our prompt, I'll just explain it, much like our prompt where we have the pop-up with the browser, you can actually pose a question and then wait for the response in the terminal window. And then when they it's much like the console window. When you enter the number, it'll set the value. And then it does something here. It does something called parse int. We haven't talked about that. That'll actually try to make it an integer. And whether or not it works or not, let's assume it does. Suppose somebody actually did enter a number between 1 to 3 and they didn't try to break it by entering like, exit or something like that, string or false, or undefined or null. They entered a number. We'll try to parse it, assuming it works. This number now between 1 and 3 will go through our switch, go to our first case, depending on what we have entered. You choose what's behind door number 1, door number 2, door number 3. If you didn't follow instructions, we'll just say, okay, you didn't follow instructions, right? But we're capturing it on the way out. We're letting them know that they didn't follow the instructions of the question. So that's a sample switch statement. This would be the switch statement rewritten as an else if statement. If you had to adjust your eyes, that's the point, because I'm already looking at like what is going on, because what stands out to me so much is the fact that, look at the indentation, look at the number of lines are cleaner, but also here we got all these parentheses here going on, and we got a bunch of blocks that you really have to really look at what's going on. So it's a lot neater for sure, right? And again, you can always look at the MDM for switch statements in itself. Switch, doesn't matter if it's type sensitive, switch statements. That's an ugly screen. Switch statements. All right, switch statement. Yes, so some more information on switch statements. Nothing here in this beginning example we didn't talk about already. Gives us a syntax breakdown. Right, not much more than what we didn't already cover there, right? Just longer switches. What happens if I forget to break? If you forget to break, the script will run from where the case criteria was met, and then run the cases after that, regardless if the criteria was run. So it'll go through. So it's showing 0, it'll fall through 0, so criteria will be met here. So this will block the run. Console log, forgotten to break would have, if you forgot to break, then we can flow into some of these other things here. So there's more to read on that if you want to try those out in the browser, right? Why not? Let's try it. What happens here? Let's get this example, put in the REPL. What happens? All right, it says 0 and 1. All right, so if you notice, it went to this case, console logged, then it fell through to number 1, console log number 1, and then we put the break in, but that's not what we wanted. So if we run this again, 0, 1, 2, so you're seeing it's falling through here, falling through here, falling through there, and then it's breaking. But if we get rid of the break here, now it's hitting all the cases, which we don't want. What happens if there was like some big computation in there? What happens if there was some code in there that side effected the first case? So we don't want that. We want a nice clean break right here. So then therefore it'll stop execution, right? Good example there, actually. You don't want it falling through. All right, so that's switch statements. That's continued.
Mike,
Yes.
sorry if you can
Yes.
explain to me in the previous slide, how does it finds out what's the value of 1, 2, or 3? Is it because of the parse int bracket?
Yes. Yeah. So
Okay.
this slide here is a built-in object called parse int in JavaScript. So here it takes a string value from the command line. By default, it's going to be a string. That's just the nature of it. Even when you're using the prompts or the command prompts that we have in the lab, the result of that, you'll notice, will be a string. So sometimes if you have this strict equality, it'll actually check the fact that this is actually an integer and compare it. Again, this is using the strict equality. If you had double equals, it wouldn't really matter then. You wouldn't have to do a parse int. It could just be this string 1 equal to 1, and then it tries to do that conversion. So yes, parse int is something, a built-in a built-in method or
In the switch
JavaScript?
the slide before, it just shows. If you can just go to the previous slide. Yeah,
Yes.
here it just shows switch show something. So how does it know when to stop from 1 to 3?
Oh, the break, right? That's
Okay.
what we're saying, the break. This keyword is what we were saying. This is what you need to break execution.
Okay.
So yes, if you don't have that break, like we said in the example already there, like that's gonna cause it to flow, right?
Okay.
If I comment out this break here, watch what happens. It goes through everything. It console logs. It skips this one. This is the one that meets criteria, and then it falls through here. Here, it just keeps executing. Like it just kind of flows. But yes, when you meet your criteria, you break, terminate the execution so there's no side effects, and then you'll get a nice clean response there.
And we close it out with the break as well.
Well, the break right here, but to be honest, you should have breaks on every single one. This is the way it should look like, right?
Okay.
Should have a break on every single one, just in case, you have something like that doesn't fall through, like something like this that runs and hits the default. It'll hit this, and then we break the execution out of this whole, we terminate this switch, this circuit. So that's, that's cleanly done. Okay.
Okay, got it, thanks.
All right, so let's quickly show the remaining questions of the labs. I'll give you time to work on it. Yeah, let's quickly do that. All right, so now we know what a switch is. So we know what a switch is. I kind of skipped ahead here. So exercise 3 was create an HTML page with an external JavaScript, so we link it out. Assign 3 variables for framework. Sorry, this typo should be 1 variable for framework. So to clarify that, 1 variable would be just the test case like this, foo, right? And then we're going to create a switch statement, and we are going to check 3 checks. We're going to check if it's React, if it's Angular, and otherwise what happens when it falls through that. How do you capture it? So what we want is, you could add more. You could add Vue.js. But what happens is if it hits React or hits Angular, it outputs this to the console. So in our case, when we run it, framework is React, we console log the value, and then we just say, okay, this is the result of the switch. So we assign a variable, we console log it, console log all the variables, which is 1, create a switch statement that goes through, and then you can add more cases to it, but that's your first hello world switch statement. All right, so this one is using this prompt again, the web API. This is just getting some a way to get, it's kind of boring, to be honest, to always be using the same variable. You want the variable to change a little bit. So this is the way you use the prompt. So you can actually use a prompt, and it'll actually take that value and assign it for you in this way. So if I have exercise 3 was a switch, I think you guys don't need to see that. I said the framework was React, JavaScript. Exercise 4 is the prompt. So it'll actually prompt you something, ask you a simple question. So if I say, water, it'll give me back my order there. So let's refresh it again. Unfortunately, okay, water. So it's going to say the order is water, here's your total, and then thank you, come again. All right, so maybe if you, let's take a look at it. Let me see. All right. Coffee will output to 250, tea will output to this, water will output to that. So yes, so if you notice, probably I was playing around with it. This was my fall through case here, if you notice. That's what it was. My fall through actually, I won't tell you what I didn't do. So I didn't do something, so it kind of fell through. So hopefully when you run one against this, if you can prevent this. Really, it should look like this. So I must have missed something. I'm not going to let you know what it was. You have to figure it out. but this is what it is. You enter order coffee, orders tea, orders that. Otherwise, it should fall through and give you some kind of result if it doesn't, if you enter something other than that. I think that's what I was probably working towards. So try to handle that, but really this is what we're after here. So you could do if statements and search for each one of them, but it's best to use a switch statement using the prompt. That's exercise 4. And then there was a challenge here. So the challenge was, if you get that far, use the prompt again. So the prompt, we want to capture 2 inputs because we want to add them together, I believe. No, we want to compare them. So we want to use the prompt twice. And this gives a little bit of interactivity to our little scripts now. Now we have 2 variables going on. Now we can do some type of comparisons against them all, and you can try to figure out how best to do it. If you need to use multiple if statements, if you can do it in a switch statement, however you choose to do it. But now we don't have to reload the page all the time. We can use the inputs now to enter some stuff. 1 second, I'm gonna be interrupted. All right, I just had some Roblox requests from my phone. So anyhow, enter the first integer, and then sorry about that. The second number, we can get that and we can add it, so we can do a comparison against it. So it's a little bit more interactivity to our forms or our applications, and then we can get the comparison of this. Now we have to trigger the refresh on every single time, but yes. And this is the challenge. So, but then, you could actually try to break it and enter a text in here. Then what happens? What happens if I try to add a text plus this? The values of this are equal. So that's wrong. But if you wanted to use a parse int and try to parse out and check for the fact that the string is not a number, that'd be good, because then I didn't handle that case. But you could, and that would be actually a good kind of test question, to be honest, if you got used to using parse int. All right, because parse int will allow you to, let's look at number parse int, parse int. Parse int function parses a string argument and returns an integer of the specified radix, the base in mathematics. So you can use parse int in this way, and you can, this is a more complex example, but it will give you an integer back, and then you can check it if it's a number or not. So you could actually check if it's a number. Yes, so we could use something like that. Let's try it out. All right, so if we get rid of this and we have a number, our input equals to 100, and we had something like this, parsed integer. Let's see what that does. Parsed input. What happens? Console log parsed. And let's run it. Does it like it? It does. Okay, so that's saying 100 is parsed. What happens if this is a string, a literal? 100, what happens if this is some string? It returns not a number. Okay, so then I know that this is going to give me either the string representation of an integer, or it's going to give me not a number, which is great, because then I can actually test for, there's another function in there. Again, if this is not in our lab, it's the bonus is nan. I'm sorry, we're going to cover these built-in functions on Monday, but this function, know about it, is nan. So this says, this is nan function determines whether or not a value is not a number or not. Right, so some interesting rules about that. So here is a little check, okay? If this is not a number, then output not a number, okay? So we're kind of moving on a little bit, but you could actually test that. You could say if is nan parsed, So if it's not a number in our conditional, then output console log not a number, otherwise else console log the parse value of it. So some other checks here. Let's see what's going on. Not a number. All right, that's good. So what happens if I said true value? Not a number. What if I typed 1,000? It should be a number. It's 1,000. But more importantly, from the console coming in is going to be a string. So it might be best for us to parse it. So then there it'll actually convert it. If you noticed, it converted it to an integer right there. So you can handle those cases in that challenge if you want to build this. It's kind of like a calculator where I'm going. No, it's not a calculator, it's a comparison, but you know, you might see where I'm going with this thing. And you can continue on with that because I will circle back to that at some point.